configuration. So now they have given the atomic number 9. Okay, so the 9 means, so what we have to do is, so we have to split the 9 into the first 9 electrons are there. So atomic number 9 means 9 electrons are there. So the first shell we have to give the 2 electrons. The second shell we have to give the 7 electrons. So it's a 2 comma 7. So it means that the 7 is the valence electrons. So it needs one more electron to uh, fulfill the outermost shell. So the valency will be the 1. How does the electronic configuration of an atom of an element relate to its position in the modern periodic table? Explain with an example. Okay. So now, how does electronic configuration of an atom? Okay, so if you know the electronic configuration, how will you find out the position? So there are so many groups are there and periods are there. So how will you locate the element in the proper place? So the position of the element, it depends upon the number of the electrons in that. So these elements which have the same electrons occupy in the same group. So if what all the elements ends with the outermost shell 1 electron means that will occupy in the group 1. If it's 2 electrons in the valence shell, so it will occupy in the group 2. If it's 3 electrons in the valence shell, it will occupy in the group 3. So like this. So element with, yeah. So the period number is always equal to the number of the shells. So suppose if you are saying that the element is present in the period 3, so it indicates that the particular element has the 3 shells. If the valence shells are equal to the electrons equal to the 1, it means that it belongs to the group 1. So the same thing. The 2 shells, it belongs to the second period. So if an element X has an atomic number 11, so atomic number 11 means the protons 11 and the electrons 11. So we have to distribute the electrons in the different shells. So the first shell will occupy the 2 electrons, the second shell will occupy the 8 electrons, the third shell occupy the 1 electron. So the valency is the 1. So it has 1 valence electron. So it belongs to the group 1 because it's having 1 electron in the outermost shell. And it has 3 shells. So, and it has 3 shells, therefore it is in the third period. Because we are placing the electrons in the 2, 8, 1. So 1, 2, 3. So there are 3 shells are there. So it's present in the third period and it is in the group 1. Okay. So now the atomic numbers of the 3 elements X, Y, Z are 9, 11 and 17 respectively. So which two of these elements will show the similar chemical properties Y? Okay. So X is having the atomic number 9. So it means that there are 9 electrons. So how will we split? So 2 electrons we have to place it in the first shell. The 7 electrons we have to place it in the second shell. The next one is 11. So 2, 8, 1. 17. So 2, 8, 7. So the X and the Z will be placed in the same group because it ends with the 7 valence electrons. So this is having a 1 electron in the outermost shell. So this will not be having the same chemical properties with these two things. Always starts with the 1 electron in the valence shell. The last element always have the 8 electrons in the valence shell. So the number of the shells remains the same throughout the period from left to right. Next question. In the modern periodic table, the element calcium, atomic number 20, is surrounded by the elements with atomic numbers 12, 19, 21 and 38. So which of these elements has physical and the chemical properties resembling those of the calcium and why? Okay. So now calcium is having a 20. Okay, fine. The atomic number is 12. So how can we split this 12 electrons? 2, 8, 2. 19. So the 19 is nothing but surrounded by the which of these has the same resembling those of the calcium Y. So the calcium is having 2, 8, 8, 2 and the strontium is 38. So it's having a 2, 8, 18, 8 and 2. So the 19 is not there because so it's having the electronic configuration. So 2, 8, then 8 and a 1. So there is one electron in the outermost shell, but the calcium is having the two electrons. So it will resemble with magnesium atomic number 12 and the strontium atomic number 38. How does the metallic character of elements change along a period of the periodic table from the left to right and why? Okay, so the metallic character always decreases along a period when we are moving from left to right in the periodic table. So as because so the when the atomic number 1 increases, so the number of the mm, uh, electrons are also increases but added in the same shell. At the same time, the nuclear charge also increases, but when we are moving along the period, there is a more effective nuclear charge. So when you are starting, one electron will be, if the element is having only one electron in the outermost shell, so there will be the less repulsion, there will be a less attraction between the nucleus and this one. So if you are having a more number of electrons in the valence shell, so the screening effect also will be there and there will be a more attraction with the effective nuclear charge. So the metals always loses the electrons. So in the left hand side, so we are having only 1, 2 and 3 valence electrons. So they can easily, it can lose the electrons. But once moving along the period, the electrons also increases in the outermost shell. So when it becomes 5 or 6, it cannot able to lose the 5 electrons. Instead, it can able to gain the 3 electrons to complete its valence shell. So the metallic character decreases from left to right in the periodic table. How does the valency of the element vary in going down a group and in going from left to right of the periodic table? So always the valency remains the same in the group because in the group all the elements are having the same number of electrons in the outermost shell. But when we are going from left to right in the periodic table, first the valency go on increasing till the middle of the period, then it starts decreasing. In the periodic table, how does the tendency of the atoms to lose electrons change on going from left to right across the period and top to bottom in a group? So always the tendency to lose the electrons decreases from left to right across the period, but the tendency to lose the electrons increases from top to bottom in the group. So always the metallic character increases when we are moving down the group because that is the nucleus and the outermost electron shells are far away from each other. So there will be a less attraction with that nucleus and the outermost electron. So they can easily lose the electron. Elements in a group have similar chemical properties. Elements of group 1. Okay, elements in a group have similar chemical properties. Yes, because in a group, all elements are having the same number of electrons in the outermost shell. So they will show the same kind of the chemical properties. Elements of the group 1 forms ion with the charge of the 1. Yes, because the group 1 means the 1 indicates that there is a only one electron is present in the outermost shell. So if it lose that one electron, it will acquire a charge of the positive 1, so and it becomes more stable. The two elements X and Y belong to the group 1 and 2 respectively in the same period of the periodic table. Compare them with respect to periodic table from left to right and Y. Okay, so the number of valence electrons in their atoms. So we are going to compare the group 1 and group 2. So the number of electrons in their atoms. So the group 1 indicates that only one electron in the outermost shell. Group 2 indicates that there are two electrons in the outermost shell. Their valencies. So it can able to lose the one electron. So valency is 1. Here the two electrons are present. So the valency is 2 over here for the Y. Metallic character. So the metallic character decreases from left to right. So the X is more metallic than the Y. the sizes of their atom. So the X is bigger than the Y because it's having a less effective nuclear charge. Formulae of their oxides. Okay, so as the X is the valency of the X is plus 1, so the oxygen is having a minus 2. So as the X equal to plus 1 and the oxygen, okay, can't write. So as the X equal to 1 and the oxygen equal to minus 2. So they are having a different valencies. So what we can do over here is we have to just the cross multiply this. So the 2 we have to multiply it with X and 1 we have to multiply it with the oxygen. So the formula is X2O. Because the valency is the 1 over here, they are not matching over here. So that's why we need to cross multiply to balance the charges. The next one is Y. Anyway, the Y belongs to the group 2. So it is having the group 2. So Y equal to plus 2 charge and the oxygen equal to minus 2 charge. So in this case, the both the atoms are having the same number of the charges. So it will cancel out each other, 2 to cancel out each other. So you will have the YO. YO are the formulae of the oxides. In the next case, formulae of their chlorides. So the chloride is having a minus 1 charge. So X is having plus 1 and Y is having minus 1. Sorry, chlorine is having minus 1. Okay. So now in this case, both the numbers valency are same. So the formula is XCl. And for the Y equal to plus 2 and Cl equal to minus 1. So now here Y equal to plus 2 and Cl equal to minus 1. So in this case, the charges are not the same. So here it is a plus 2 and here it is a minus 1. So now we have to do the cross multiplication. So 1 with Y and 2 with Cl. So the formula is YCl2. Next question. So the atomic number of an element is 16. The atomic number of an element is 16. So predict the number of valence electrons in its atom. Okay, so the element is 16. So what we can do, we can able to write the uh, electronic configuration for this. So 2, 8 and the 6. So based on this we can able to find out how many valence electrons are there for this particular atom. Okay, so the number of valence electrons in its atom. So the 6 because the 6 is the outermost electrons. Its valency. Valency is it needs 2 more electrons to complete the shell. So valency is 2. Its group number. Group number is 16 because it's having the 16 electrons. So group is 16. Whether it is a metal or the non-metals, it is a non-metal because it's gaining the 2 electrons. Always non-metals gains the electrons, metal lose the electrons. The nature of the oxide formed by it. Okay, metallic oxides are always basic oxides, non-metallic oxides are always acidic oxides. So as it's belong to the non-metal, so its oxides are acidic in nature. The formula of its chloride. So S, okay, so the atomic number 16, so it is a sulfur. So S is having a plus, okay, it needs the 2, the valency is 2, the chlorine is having a 1, so we have to cross multiply. SCl2 is the formula of the chloride. The position of the 3 elements A, B and C in the periodic table are indicated below. So group 16, group 17, first period, second period, third period is one. State whether the element C would be a metal or a non-metal. Why? Okay, so as it present in the C in the group 17, it means that there are 7 electrons in the outermost shell. So 7 valence electrons are there. So it can gain 1 electron. So when it's gaining the 1 electron, so it's a non-metal. Okay. So which is the more active metal, A or the C? Okay. So the A is present in the second period. So C is present in the fourth period. So A is the active element than the C because the A can gain electron easily because it's having only the 2 shells. So the nucleus can easily attract to the electrons. But in the C, it's having a 4 shells. So the nucleus is present inside the all the shells, so it's having a 4 shells. After that only it has to attract, so the attraction will be very less in the case of the C. Which type of ion will be formed by the element C? Why? So the C can able to gain only 1 electron, so it's a gaining electron, so electrons are always negative in charge, so it's having a negative 1, it's forming a negative ion because the anions will, because it's having a more electrons than the protons. Okay, next one. So the element X has the atomic number 13. So write its electronic configuration 13. So it means that it's 2, 8 and 3. State the group to which the X belongs. So as it is present in the group 13, atomic number 13, so it belongs to the group 13 over here. So is X a metal or the non-metal? So X is a metal because there is a 3 electrons which is present in the outermost shell. So it can easily lose the 3 electrons instead of gaining 5 electrons. So write the formula of its bromide. Yes. So X is having a plus 3 charge because as it loses the 3 electrons, it has having the positive 3, and the bromide ion is having the negative 1 charge because it is present in the group 17. So we have to cross multiply. So XBr3 is the formula for its bromide. Okay, so state the modern periodic law for the classification of the elements. How many groups and periods are there in the modern periodic law? So the properties of elements or the periodic function of their atomic numbers. So we have arranged the elements in the modern periodic table by the atomic number, not by the atomic mass. So there are 18 groups are there and 7 periods in the modern periodic table. Okay, next one is the element which is having the atomic number 11, write its electronic configuration. So 11 means it's 281. State the group which it belongs to. As it's having the 1 electron which is present in the outermost shell, so it's present in the group 1. So M is a metal or a non-metal. So it's having a 1 electron, so it's easily lose 1 electron instead of gaining 7 electrons in the outermost shell. So it is a metal. Write the formula of its chloride. So M is having a plus 1 charge. So the chlorine is having the minus 1 charge. So both the charges are equal. So MCl. Okay. Then the formula, okay, an element M is having the atomic number 12. So write its electronic configuration. State the group of M which belongs. So is the M metal or a non-metal? Okay, fine. So it's a 12. So we can write it as 282. So this having 2 electrons in the outermost shell. So it's present in the group 2. So as it's easily lose the 2 electrons in the outermost shell instead of gaining the 6 electrons. So M is a metal. So its oxide formula is, so M is having the +2 charge and the oxygen is having the -2 charge. So the 2 cancels. So MO is the formula of the oxide. Okay, next one is choose from the following. So carbon, oxygen, neon, sodium, silicon. Okay, the elements that should be in the same period. Okay, so the carbon, oxygen, neon are in the same period because it's these three elements are having only the two shells, and the sodium and the silicon are in the same period because it's having the three shells. Elements that should be in the same group. So the carbon silicon are in the same group because they have the four valence electrons. Okay. And element X belongs to the third period. Okay, third period means it's having the three shells. And the group 17 of the periodic table. Okay, so it means that the valence electrons are 7. So it needs one electron to complete. So it's having a valency 1. State its electronic configuration valency. Yeah, so it's a group 17. So 287. Valency is 1. Justify your answer with reasoning. So it has the atomic number 7. So we have to split the electrons into the three shells, and then it's because it needs one more electron to complete the shell. So its valency is equal to the 1. And also it belongs to the third period. So it indicates that it's having a three shells. So it belongs to the group 17 because it has the 7 electrons in the outermost shell. Next, the formula of the magnesium oxide is MgO. State the formula of the barium nitrate and barium sulfate if barium belongs to the same group as the magnesium. Okay, so it means the same group means the valency will be the same. So the magnesium is present in the group 2, so it indicates that barium is also present in the group 2, so it's having a valency +2 charge. So this is the nitrate ion. Nitrate ion is having the -1 charge. So here the numbers are not equal. So we have to cross multiply. So the 2 with the nitrate and 1 with the barium. So BaNO3 2. Next one is the barium sulfate. So barium again is present in the group 2. So it's having the electronic configuration +2. Sulfate is having a -2 charge. So both the numbers are same. So the 2 gets cancel each other. So BaSO4. Choose from the following: calcium, lithium, sodium, neon. An element having the two shells completely filled with the electrons. Okay, so completely filled with the electrons. That is a neon because it's having a atomic number 10. So the number of electrons is also the 10. So we can split up into the 2, 8. So the 8 electrons are present in the outermost shell. So it means that the shells or both the shells are completely filled. The two elements belonging to the same group of the periodic table. So the same group indicates that the same number of valence electrons in the outermost shell. So this one is lithium and the sodium because the lithium is having the atomic number 3. So it's having a 3 electrons. 2, 1 is the electronic configuration. So for the sodium it is 2, 8, 1. So these two atoms are having one electron in the outermost shell. So both are in the same group of the periodic table, first group. Why do all the elements of the same group have similar properties, same period have the different properties? Okay. So the elements of the same group have the similar properties due to the same number of the valence electrons. Means how many electrons it can able to lose or gain. So based on that, we can able to form the compounds. So if all the group elements are having the same number of valence electrons, so it will always forms the same compounds, same kind of the valencies. So it's always having the same valency. So the period have the different properties means, so they are difference in the number of the valence electrons. So in the in the first period, in the first this one, the it enters into the only one electron in the outermost shell, so it can able to form the plus one charge. In the next one, when you're moving from left to right, the next element is having a two electrons, so that's having a plus two charge, so it can able to form the uh, it can able to make a two donate the two electrons, so their valency is completely different from that of the other one. Next one is an element E has the following electronic configuration KLM. So K is nothing but the first shell, L is the second shell, M is the third shell. So 286. To which group of the periodic table does the element E belong? Okay, group. So it's having a, 6 electrons. So it means that so it's present in the group 16. To which period of the electron periodic table does the E belong? So 1, 2, 3. There are three shells. So it means that period 3. State the number of the valence electrons present in the element. So the valence electrons, we have to always say the outermost shell. So M is having a 6. So there are 6 electrons, valence electrons. So what is the valency of the element? So the valency is nothing but how many electrons it can able to lose or gain. So here it's already having a 6 electrons in the outermost shell, so it can able to gain the two, two electrons. So its valency is 2. Choose from the following: beryllium, fluorine, potassium, calcium. The element having a only one electron in the outermost shell. So that is a 19 because so it is having a 2 comma, yeah, so because it's having 2881. So when we are splitting the electrons in the number of the shells, 2881, so only one electron is present in the outermost shell, so potassium is having one electron. Two elements of the same group, so beryllium and the calcium, because both the elements ends up with the same number of the valence electrons. The element has atomic number 13. So what is the group and the period number to which the element belongs? So from the atomic number it indicates 13, so it's present in the group 13, and when you are writing the electronic configuration 283. So there are three shells are there, so it means that it's present in the period 3. Is this element a metal or a non-metal? So justify your answer. Okay, so now it's having three electrons in the outermost shell, so it can easily lose the three electrons rather than it has to gain the five electrons. So it is present in the it is a metal, so because it can easily lose the three electrons to become more stable. Next question. The electronic configuration of the two elements A, B are 283 and 287 respectively. So find the atomic number of these elements. So we have to add 2 plus 8, 10, 10 plus 3, 13. So the A is having atomic number 13, and this is 2 plus 8 plus 7, so 17. So B is having the atomic number 17. Okay, and we have to, okay, so as it is having the three electrons in the outermost shell, it forms the plus 3 charge. A can able to form the plus 3. And here it's having the 7 electrons in the outermost shell, so it needs one electron. So it can able to gain the one electron and it becomes stable. So B is having minus 1. So A, B3. So it is an ionic compound. So what is meant by an ionic compound? When the metals and the non-metals combines together, we call it as an ionic compound. Okay. The atomic number of the three elements are given below. A, B, C. Atomic number is 5, 7 and 10. Okay. So write the symbol of the element which belongs to the group 13 Group 15 of the periodic table. State the period of the periodic table to which these elements belong. Give the reason of your answer. Okay. So the A belongs to the group 13 because its electronic configuration ends with the 3. It is having the 3 valence electrons. The element B is having the 7. So it belongs to the group 15 because its electronic configuration is 2, 5. So it has the 5 valence electrons. They belong to the second period as they both have the 2 shells. Okay, next one. Write the atomic number of these elements. What will be the formula of the compound formed and the nature of the bond between the and when these two elements chemically combine together? Okay, so the A is having the atomic number 17. So its electronic configuration is 287. So 7 electrons. So it needs 1 electron to complete the outermost shell. So its valency is 1. So A is having minus 1 because it's gaining the one electron, so it is minus 1. So next one is B, it's having electronic configuration 2882. So here there are 2 electrons in the outermost shell. So it can easily lose the 2 electrons. So it forms B plus 2 charge. When you are cross multiplication, so the charges are unequal. So that's why we need to cross multiplication. So it's having a Ba2. So when the metal, so this is the metal, one is losing, so it is a metal. The another one is the non-metal because it is gaining the electrons. So it is an ionic compound. The atomic numbers of 3 elements are given below. So element A, B, C. So atomic number 3, 6, 9. So write the symbol of the element which it belongs to the group 1, group 14 of the periodic table. State the State the period of the periodic table to which these elements belong. State the reason of your answer. Okay. So the A belongs to the group 1 because it's having it's having the atomic number 3, so it's having 2 comma 1, and the B is present in the group 14 because it's having a 6 electrons in the outer 6 electrons. So when we are splitting it up, we will be having the 2 comma 4. So it's the 4 electrons in the outermost shell, so it's present in the group 14. And the C is having the atomic number 9. So the number of the electronic configuration for the C is 2 comma 7. So it's having only one valence electron. So all of them are having the 2 shells. So all belongs to the period 2. So the fluorine, chlorine and bromine are the elements each having the 7 valence electrons. So which of these has the largest atomic radius and is most reactive? So justify your answer with stating reason for each. So the bromine has the largest atomic radius because it has the 4 shells, 2, 8, 18 and the 7. And the fluorine is the most reactive because it is very smallest in size, and also it can gain electron easily. Okay. Next question. Sodium, magnesium and aluminum are the elements having 1, 2 and 3 valence electrons respectively. So which of these elements has the largest atomic radius and is least reactive? So justify your answer stating reason for each. Okay, sodium, magnesium and aluminum. So sodium is having 1 valence electron, magnesium is having 2, aluminum is having the 3, which is having the largest atomic radius. So sodium is having the largest atomic radius because it has only 11 protons and the 11 electrons. If you take the aluminum, it's having the 3 valence electrons. It means that it's having a 13 protons and 13 electrons. So the nuclear charge will be more compared to that of the sodium. So sodium is having the largest atomic radius. Which one is the least reactive? Aluminum is the least reactive because it has to lose the 3 electrons. So we have to supply the more amount of the energy to remove the electron from the outermost shell. And also it's having the greater nuclear charge. Okay, next question. How are the following related? Okay. Number of the valence electrons of the different elements in the same group. Number of the, okay, so the different elements in the same group have the same number of the valence electrons, and the number of the shells of elements in the same period. So it means that the number of the shells are equal or same in the period when you're moving from left to right. How do the following change? The number of the shells of the elements as we move down the group, it increases because the size of the atomic number is also increases. So the number of the shells increases when we move down the group. The number of the valence electrons of the elements on moving from left to right in the period. So the number of the valence electrons of the elements so goes on increasing on moving from left to right. Actually it increases up to the middle, then after that it starts decreasing. So because as the metals are present in the left hand side, so they will lose the electrons. Then once it comes to the non-metals, it started to gain the electron. So that's why first increases, then decreases. Atomic radius in moving from left to right along the period. Atomic radius decreases when we are moving from left to right in the atomic along the period because it's having the more effective nuclear charge. Atomic size down the group. So atomic size increases when we are moving down the group because the number of the shells increases. How many periods are there in the modern periodic table of these elements? So there are totally 7 uh, periods in the modern periodic table. How do the atomic radius, valency, and the metallic character vary down the group? So the atomic radius goes on increasing down the group because the valency remains the same. The metallic character always increases when we are moving down the group. Why the metallic character increases down the group? Because uh, it can easily lose the electron. The element which can easily lose the electron shows the metallic character. So the distance between the nucleus and the outermost electrons increases. So that's why when we are moving down the group, it's having a more metallic character. How do the atomic size and the metallic character of the elements vary as we move from left to right in the period? So atomic size decreases along the period from left to right and the metallic character decreases along the period from the left to right.